Welcome, explorers of the unseen world. Today, we embark on a deep dive into a simple, yet intriguing question. Why is water blue? At first glance, it might seem trivial. Water in a glass appears clear. So why does it take on a different hue when we look at a lake, a river, or the vast expanse of an ocean? Here's the fascinating part: the answer lies not in the water itself, but in the science of how light interacts with water molecules. Light, as you may know, is made up of a spectrum of colors, each corresponding to a different wavelength. When light hits the water, these wavelengths are absorbed to varying degrees. Different colors, wavelengths, are absorbed at different rates. The water molecules absorb light in the red part of the spectrum more than the blue part, due to their molecular and atomic structure. This means that blue light is scattered and reflected back to our eyes. This might lead you to think, so, water appears blue because it reflects blue light. But why not violet light? After all, violet light is of shorter wavelength and should be scattered more. That's a splendid question. Even though violet light is indeed scattered more than blue light, our eyes are less sensitive to violet light. Plus, sunlight reaches us with lesser violet light to begin with, due to absorption by the atmosphere. Hence, the blue light becomes dominant in our perception. But, absorption and scattering are just part of this wondrous tale of why water appears blue. There's another protagonist in our story: Rayleigh scattering. Named after Lord Rayleigh, this phenomenon is the scattering of light or other electromagnetic radiation by particles much smaller than the wavelength of the light. For pure, particle-free water, these particles are the water molecules themselves. In the case of water, the light is scattered in all directions, but it's scattered more in the shorter wavelengths towards the blue end of the spectrum. This effect is more prominent when light travels a longer path through the water. And thus, when you gaze upon a deep lake or the expansive sea, the water appears bluer due to this increased scattering effect. So, the blue appearance of water emerges from a beautiful ballet of absorption, our eyes' perceptual bias, and Rayleigh scattering. Isn't it marvelous how such simple principles can give rise to the stunning blue vistas we enjoy when looking out across the water? Cut to an image of the deep blue ocean. So, the next time you find yourself staring in awe at a tranquil blue lake or the vast, seemingly infinite ocean, remember the fascinating physics at play behind the simple question: why is water blue? There is always more to learn, more to explore. The world around us is filled with unending mysteries, just waiting for our curious minds to unravel. Thank you for joining me on this deep dive today. Until our next scientific adventure, remember, curiosity is the key to discovery.